so today we're going to be talking about sequences. Sequences are just a list of numbers that form a pattern, that often forms a pattern. Okay? So you've been doing sequences for a really long time, whether it's with pictures, numbers, you've been doing it for a super long time. But today we're going to specifically talk about arithmetic sequences. And in each sequence, there's what we call terms. Okay? A term is an element or a number in the sequence. So I'm going to write a sequence here. We're going to say 1, 3, 5, 7. Okay? So in this sequence, 1 is my first term, 3 is my second term, 5 is my third term, and 7 is my fourth term. Alright? So that is what we are talking about right here. Okay? An arithmetic sequence is a sequence whose successive terms differ by the same non-zero number d. Alright? That's really, really fancy math language for us basically saying it's a sequence whose terms you either add the same number or you subtract the same number. Okay? So they differ by the same non-zero number d. Okay? So this d is our common difference. Okay? It's really, really important that we are going to be talking about this non-zero number d. And this is going to be our common difference. So this is a non-zero constant difference of any term and the previous term. So if we go back up to this term that I wrote here, guys, what's the common difference between all these numbers? 2. I'm adding 2 each time. Do y'all feel comfortable with that? So this right here would be an arithmetic sequence because I'm adding the same number every time. Okay? So an arithmetic sequence, kind of in, I guess, non-math words, for an arithmetic sequence, guys, that means you add or subtract the same number, which we are going to call d, alright, every time. Do y'all feel good about that? That's kind of like the fancy math language for an arithmetic sequence, okay? Now, we want to determine if these sequences are arithmetic. Not all sequences are, okay? We're going to learn about a different one the next unit. And if it is arithmetic, we want to give the common difference. So what I'm going to do is I'm going to look here and let's see what happens. What am I adding or subtracting to get from -4 to -2? I'm adding 2. Okay, then what do I do to get from -2 to 1? Oh, I'm adding 3. To get from 1 to 5, what am I doing? Adding 4. Okay, so is there a pattern? But is it an arithmetic sequence? No. So this would be a no, because there is no common difference. That doesn't mean it's not a sequence. It is a sequence. It's just not special and arithmetic. Does that make sense, y'all? Y'all tracking with me? So arithmetic sequences are special. All right. So let's see about this one. What is our common difference right here? Ooh, to get from 4 to 1, we're subtracting 3. To get from 1 to -2, what are we doing? Subtracting 3. To get from -2 to -5, what are we doing? Subtracting 3. So is this one an arithmetic sequence? Yes, because we are subtracting the same number every time. So our d, our common difference, is -3. Do y'all feel good about that? We're subtracting 3. Or you can say you're adding -3. Okay? Now, let's take a look at this one over here. This is a little bit annoying. Okay? To get from -3/4 to -1/4, what are we adding? 2/4. I like that. Okay? We're adding 2/4. To get from -1/4 to +1/4, we're adding 2/4 again. To get from 1/4 to 3/4, we're also adding 2/4. So is this one an arithmetic sequence? Yes, because we're adding the same number each time. So my common difference in this case would be 2/4, but would we ever leave it that way? Absolutely not. We would definitely want to make sure that is set, that it is a simplified fraction, and our common difference is 1/2. Do y'all feel good about that? Okay, this is, like I said, this is not something that is overly complicated, but it is a little bit different. Okay, so all you're doing for an arithmetic sequence is you add the same number or you subtract the same number. You guys tracking? Okay, so this is where it gets a little tricky. We have what we call these recursive formulas. Okay, so recursive formula is special because it tells us it is this little formula right here. And a lot of times, guys, they will show you a recursive formula. So if you guys have a highlighter, this might be a good time to highlight a lovely little formula. Okay? And you see this, and how we say this recursive formula is you say a sub n equals a sub n minus 1 plus d. Okay? So when I say sub, that's because it's a subscript. So should I write that to the side so you guys know how to say that? Or do y'all feel good about that? A sub n equals a sub n minus 1 plus d. So guys, a sub n is the nth term of the sequence. So if I said, for example, if I was saying something like a sub 6, then I would want you to find the 6th term. Does that make sense? So if I said a sub 5, it would be the 5th term, right? You guys kind of tracking there? So this would be our 6th term. Okay? A sub n minus 1 is the term right in front of it. So if my example was a sub 6 for a sub n, what would be a sub n minus 1? Well, guys, what's 6 minus 1? 5. So this guy would be a sub 5 because it's just the term right in front. Okay? So a big reason we're talking about these is because I don't want you guys to be scared off by these, this notation right here. A sub n just means that it's whatever term the n is. A sub n minus 1 means it's whatever term that's in front. So if we start with a sub 6, a sub n minus 1 is a sub 5. Cool? All right. And then d is that common difference that we were talking about above. So guys, all this really fancy formula is saying, if we plugged in our examples right here, would be saying the 6th term is equal to the 5th term plus my difference. Does that make sense? Are you guys tracking? So my next term is equal to the term right in front plus the difference. Yes. Okay? So what happens is, guys, sometimes they like to show you things like this, and it can look a little bit scary. So given the following recursive rule and term value, they say find the next 4 terms in the sequence. So guys, if our recursive rule is right here, I'm not going to highlight it because that's not like the official one. If our recursive rule is a sub n equals a sub n minus 1 plus 4, that's our rule. And we know that a sub 5 is equal to 18. And it says we want to find the next 4 terms. What terms are we looking for, guys? We are looking for a sub 6, a sub 7, a sub 8, and a sub 9. Do y'all feel good about that? A sub 6, a sub 7, a sub 8, and a sub 9. Alright? So we are looking for these 4 terms. Okay? So if you were to do this, where do you think we would start? We'd want to find D. Well, guys, what's our D? Do we know from our formula right here? What is it? plus 4. So guys, what am I going to do each time? Just add 4. That's it. Okay? So this scary looking formula right here, all it's telling us is that you add 4 to each term. So if I was going to write this officially, then I would say, okay, well, a sub 6 is equal to a sub 5 plus 4, right? Well, guys, what's my a sub 5 again? 18. So I'm just going to put 18 plus 4. So what is a sub 6 equal to? 22. Do y'all feel good about that? A sub 6 is equal to 22. Are you guys kind of tracking there? Or is this weird? Okay? Now guys, does that feel like a lot to write? No? Okay. So a sub 6 is equal to 22. So if I'm looking for a sub 7, well guys, that's just going to be a sub 6 plus 4 again. Well guys, do we know what a sub 6 is? We sure do. What is it? It's 22. So we're going to say 22 plus 4. Well guys, what's 22 plus 4? Yeah. So a sub 7 is equal to 26. So guys, do I need to necessarily write all this stuff every time? As long as you know the rule, what can you do each time? Just add 4. So guys, I'm going to go here out on a limb, a sub 8. Now I'm just going to say a sub 7, which is 26, plus 4 gives me a sub 8 is equal to 30. Are you guys tracking? Okay. And then for a sub 9, we are going to need to know the one right in front of it. Well, the one right in front of it is 30 plus 4. So a sub 9 is equal to 34. You guys feel good? So a sub 9 is equal to 34. So, given the following recursive rule and term, find the next 4 terms in the sequence. Well, guys, it's 22, 26, 30, and 34. Y'all feel good? Now, does that mean you need to write out all of these steps every time? No. If you can look at the rule and see that you add 4, guys, just add 4 every time. Y'all feel good about that? Now, here's the deal. Recursive rules are nice because, so recursive means that it depends on the number in front. Okay? So I have to know the value right in front of it if I want to know the next ones. So that's really great. But sometimes, guys, I might say, hey, if a sub 5 is equal to 18, can you tell me what a sub 52? Can you tell me the 52nd term in this? Well, guys, do you want to add 4 52 times or 47 times? Not really. So what we also have is what we call an explicit rule. So a recursive rule depends on the number in front. Okay, so I'm going to write that up here. This one depends on the number in front. Okay, a recursive in front of it. Okay, so that's a recursive rule. An explicit rule down here can be written for anything, any term. It doesn't depend on it. And what we are doing is we have this formula right here. And I'm going to write these up on the board for you, okay? So we have this formula right here. And the only thing you really need to know for this explicit rule is you need to know the first term and you need to know the common difference, okay? So you have this explicit rule right here. And sometimes you are given an explicit rule and sometimes you aren't, okay? So when you're given, and sometimes you have to create your own explicit rules. So here, a sub n equals a sub n, a sub 1 plus n minus 1 times d. So guys, we are going to say that a sub n is the nth term in the sequence, okay? This is just like up in the recursive rule. A sub n means the same thing, okay? And the difference is right here is that n is that term number, okay? We've already kind of talked about that. So like a sub 7 would be the 7th term, a sub 52 would be the 52nd term, a sub 100 would be the 100th term, okay? An important value that we need to make sure that we are paying attention to is a sub 1. This is the value of the very first term in the sequence, okay? And again, D is that common difference, okay, between the terms. So D has not changed. It has been the same in all of our little goings on here, all right? So I'm going to change my color for a sub 1. Instead of blue, I'm going to make it green because I think the blue and the purple are too close to each other. Okay? So I'm going to make it green. So a sub 1 is going to be green now. Sorry. So that's our first term. Alright. So given the following explicit rule, find the first 4 terms of the sequence. Well guys, if you are given a rule, then what we are doing is we are going to find a sub 1, a sub 2, a sub 3, and a sub 4. Do y'all feel good about that? We want to find those first 4 terms. And guys, we are given the rule. The rule right here is a sub n equals 3 times n minus 4. Okay? So let's take a look at this, all right? So we are going to see, okay, so if we plug in, instead of an n, what are we going to plug in here? What are we going to plug in on our first term, y'all? We're going to plug in a 1. That's it. This is just simple plugging in. So we're going to say 3 times 1, minus 4. That's it. So we just plug in our n. So that becomes 3 minus 4. So a sub 1 is equal to negative 1. Do y'all feel good? Okay. Now what do we do for a sub 2 here? Instead of 1, what do we plug in for my n? 2. Yeah. So it just becomes 3 times 2 minus 4. So 3 times 2, so that becomes 6 minus 4. So that is equal to what? Yeah, that is equal to 2. Okay? And then we go here, so that's a sub 2. And then a sub 3 is what here? We have what? We got 3, so I'm sorry about that, guys. So that's 3, but instead of times 2, now we just multiply it by 3. We subtract our 4, so that becomes 9 minus 4. So my a sub 3 is equal to 5. Do y'all feel good about this here? And the last but not least, we're going to plug this in. We're going to say 3 times 4 minus 5. And so what do we have here? We have 12 minus 5. So that's going to be, nope. Why did I say 5? That's not right. Sorry, guys. That's 12 minus 4. Does anybody else feel the Fridays today? No, just me. It's like a Halloween Friday. Like, we're so close. Okay. So that's minus 4. My bad, guys. So instead of 7, that's going to be 8, which actually makes sense. Okay? So when you guys take a look at this, I want you all to look at this and tell me, what was the value of my first term? Negative 1. Okay? What is my common difference between all of these? We are adding 3 every time. Okay? So, when you look at this equation over here, what kind of equation is this? Have we done, if we replace this a sub n with a y equals 3x minus 4, what are we looking at? We're looking at slope-intercept form. We're looking at a linear equation. So guys, arithmetic rules are just linear. And the common difference is 3 And what is the common difference when you're looking at the equation? It's the slope. So guys, your arithmetic sequence is just a linear equation, and that common difference is that rate of change, okay? So all we're doing is we're creating, we're writing a sequence, and it's like this is your x and that's your y. This is your x and that's your y. This is your x and that's your y. So we're creating a sequence from these numbers. All right, guys? So sometimes you're given a rule, and you just plug in the values that they want, okay? That is pretty simple, right? That's just plugging in a 1, plugging in a 2, plugging in a 3, plugging in a 4. Other times, you get to write the rule. This is the most common thing you're going to see, okay? Where they tell, and so guys, you have to remember, this is the explicit rule, okay? So this is the formula that we use to plug in, okay? And remember, a sub n is the nth term, n is the term number. A sub 1 is the value of the first term. All right. That's our term number. And D is that common difference, okay? So we're going to take all these things and we are going to try to plug it in to create our rule. And then we're going to simplify it, okay? And then we're going to be asked to find a specific term, okay? So how many terms do we got right here? In this, yeah, we got 5. So what are we doing each time? We're subtracting 3, okay? So technically, if you saw this and it said find the 50th term in the sequence, could you go here and say 10 minus 3 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 50 times? Yes, but I don't recommend that because you know what's really easy to do is to be like, wait, how many 3s did I just do? 1, 2, 3, 4. And you would get lost and you would get confused and it would just be really annoying. Does that make sense, guys? But I could technically do this, like, 50 times. I don't know. Oh, gosh. Okay, see, clearly I didn't even, oh, man, what did I do wrong? Okay. Oh, I didn't add anything at the end. See? Okay. But I don't even know if that's a 50th term. I was just pushing 3 a million times, right? So that is not a super consistent way to do this. So what we're going to do is we're going to write this for us, okay? So check this out. A sub n is equal to a sub 1. What's my a sub 1, y'all? We're going to identify all these little values. So what's my a sub 1 equal to? Ooh, you know what? We're going to start. What's my first term, y'all? 10. Oh, I thought you said n. I was like, oh, man. Okay, so a sub 1 is equal to 10. Okay? Now, the other thing we really need to know is the common difference. What is our common difference? Minus 3, right? So we have a sub 1 and we have our common difference. Now, since we know those two things, we can write an equation. So I'm going to say that a sub n is equal to a sub 1, which is 10, plus parentheses n minus 1 times d. Do y'all feel good about that? All I did was I plugged in my a sub 1. Oh, wait. What am I supposed to put there for d, y'all? Guys, it's Friday. I'm struggling. That's supposed to be a negative 3. Of course, you can't really see it very well, can you? Okay. I will do it with another color. There. Is that better? Negative 3. So that's supposed to be a negative 3. So now we've plugged in the 10 and the negative 3 to my formula. Okay? So now what we are going to do is we are going to simplify this. Y'all feel good about that? Okay. So how we're going to simplify this is we're going to say, okay, a sub n is equal to 10. This negative 3 here, we need to distribute. So negative 3 times n is going to be negative 3n. Negative 3 times negative 1 is going to be what? Plus 3. So now a sub n, now we just need to combine like terms. So are you guys cool if we put the n in the front just because I'm used to that? Okay. So that would be negative 3n plus 13. So my rule here that we are following is negative 3n plus 13. That's our rule. We just wrote a rule for our arithmetic sequence. Now, when it says find the 50th term, what are we going to do with that number there? What are we going to do with 50, y'all? Just plug it in, right? We just plug it in for n. So now my n is going to be equal to 50. So this becomes a sub 50 is equal to negative 3 times 50 plus 13. Okay? So that would be what? So we're going to plug that in. So that's what? Negative 150 plus 13. It's what? Negative 137. So a sub 50 is equal to negative 137. So clearly I did not subtract enough when I was doing it, right? Negative 3 times 50 plus 13. You do that, you get negative 137. So guys, clearly when I was doing this, I did not subtract 53s. I don't know how long it would take to get to 50. Let's see. Keep going. Super close. Nope, I went too much, didn't I? Dang it, see? That's why it's really good to write the sequences, right? Do y'all see what I'm saying? Okay, so it's really annoying to just do it on your calculator. I was not doing a great job of keeping track, okay? So first I was two under, then I overshot it. All right? So, guys, honestly, it's just identifying that first term and the common difference. So what is my first term on this guy, number 4a? What's my a sub 1? 11. Cool. Okay? What is my common difference? What are we doing each time? We are subtracting 6. Excellent. We are subtracting 6 every time. Okay? So we have a sub 11, or a sub 1 equals 11, and our common difference is 6. So guys, now we're going to write our arithmetic sequence. So my a sub n is equal to 11 plus n minus 1 parentheses, and then what do we put on the outside there? Our difference, okay? So this is a sub n equals 11 plus n minus 1 times d, all right? And I guess I should put that in parentheses there, okay? So now if we want to simplify our arithmetic sequence here so it doesn't look so weird, we're going to get rid of all these parentheses. We have 11 n minus n times negative 6 is negative 6n. Negative 6 times negative 1 is positive 6. Now we combine our like terms, and we get negative 6n plus 17, right? Not 15. Jeez. Like I said, everybody has those days. Okay? Here we go. Y'all feeling good about that? So negative 6n plus 17. So now that we have our formula, can we find our 60th term? Yes. So we're going to say n is equal to 60. So I'm going to say a sub 60, because that's what our n is equal to negative 6 times 60 plus 17. Okay? Negative 6 times 60 is what? Negative 360 plus 7. Let's see here. Negative 6 times 60 plus 17 is negative 343. So a sub 60 is equal to negative 343. I would not have wanted to subtract 6 60 times. I definitely would have gotten a little messed up there. Do y'all feel good about that? Ish? All right. Then we go here. 5a. Find a rule for the arithmetic sequence, okay? So finding this rule for the arithmetic sequence. Well, guys, is this setup the same? What do you think this means? This is not quite the same. So what's my terms? What's going on here? Well, guys, the n is the term number, right? So this right here is my term number. So what are the actual terms? Where are my terms, y'all? The bottom, right? The f of n. So these are the actual terms right here. So the term number is on the top. So that means my first term is what? 0. So I'm going to just kind of rewrite this as 0, negative 4, negative 8, negative 12. right? My first term is 1, my first term is 0, my second term is -4, my third term is -8, my fourth term is -12. So now, is it easy for us to identify what is my first term? Well, that's 0. What is my common difference? What are we doing here? Are we subtracting 4? Wow, we have negative differences every time on these examples. That's fine. There can be positive differences, okay? So once you find your common difference, then you say, okay, cool, D is equal to -4. So then we're going to say, cool, well, A sub n, I'm going to follow my explicit formula, the one at the top of the page. A sub n is equal to A sub 1, which is just 0, plus n minus 1 times my D, right? Which in this case is -4. Okay, so now when we simplify this, we're going to look at this, we're going to say, okay, cool. A sub n equals, do I really need to add that 0? Nah, it's gone. Okay, -4 times n is just -4n. -4 times 1 is just +4. Do we need to do anything else to simplify this? Nope. Just says A sub n. And then it says find the 28th term in the sequence. So that means my n is going to be equal to 28. So if I write my term values here, I'd say A sub 28 is equal to -4 times 28 plus 4. Because I'm not super interested in subtracting 4 28 times. Then I'd go to my lovely little handy calculator here. And I'm thinking, okay, -4 times 28 plus 4 gives me -108. So A sub 28 is -108. Do y'all feel good about that? Ish? Alright, so sometimes you will have these explicit terms. Sometimes you will have these recursive ones. And so all you need to do is make sure that you guys can plug those in. Okay? Cool. Any other questions before y'all get going on our next thing? All right.